Hi, everyone. For this problem, we're going to do a Venn diagram. That way you can organize the information. So let's go ahead and start. So a survey of 100 students at Fordham results in the following data. 25 are majoring in math, 40 are majoring in finance, 40 are neither. So let's create a Venn diagram before we even look into what is it that we're asking to find. So here's our rectangle. And since there's two components to this problem, two majors we're considering, so I'm going to draw two circles in our Venn diagram. Okay, so let's use following variable. Let M stands for math major, and F stands for finance major. So let's call this one the M circle, that's the F circle, and then the rectangle will be the outside, not M, not F. So 40 are neither. So if 40 are neither, that means I'm going to start with 40 first. So let's go ahead and put 40 outside of each circle. And then we also know that there are 25 in the M circle. So 25 are going to be here. And then there are 40 that are going to be here. But I don't know how much is in the intersection. So I don't want to put that information yet. So here's what we're going to do. We're going to use a formula to figure out what goes here, here, and here. So we know that the number of elements in these two sets, M or F, is equal to the number of elements in M plus the number of elements in F, and then minus the number of elements in M and F. So hopefully you know that formula, the union formula. Okay, so before we use this formula, let's hold on to this. So I'm going to go ahead and use another formula first, since I still don't have enough information to use this union formula. So we know this entire sample space, we have 100 students. So that means the number of elements in our space should be 100. Now, since I know that there are 40 outside of the circles of M and F, so that means if I do 100 minus 40, I get the number of elements in M union F. So that will give me how much is in the union. So we know that the number of elements in M or F is going to be 60. So I know these two pieces, these three regions together, it's going to give me 60. So that is a good information to have. So I'm going to hold on to that, and I'm going to go ahead and substitute that right here. Okay, now do I know how much I have here? Yes, we know that's 25. So I'm going to go ahead and set up the following equation. So taking equation 1, we know the number of elements in their union is 60. Now I know number of elements in the M circle is 25. And then the number of elements in the F circle is 40. And minus the intersection of their sets. So that would be enough to find the intersection. I'm going to go ahead and add the number of elements in the intersection on both sides. So the number of elements in M and F is equal to, so I can add them up, 40 and 25. That's going to give me 65. Subtract 60 on both sides. That'll give me 5 in the intersection. Now I know how much is in the intersection. So that's where I'm going to place right here. So we figure out how much in the intersection. This is going to be 5. So now that we have this, now figuring out how much goes in only M region is very easy, because we just need to subtract 5 from 25. That'll give you how much goes here. So that will be 20, because this entire circle has to be 25. Now also how much goes in the F circle, we can also subtract the intersection from 40. That'll give us how much goes in the F circle. That would be 35, because their sum has to be 40. All right, so that takes care of our information in the Venn diagram. And as you can see, if you add them all up, all of these should add up to 100. And yes, they do. You can check that. So now let's see if we can answer the problem. So we want to know, what is the probability that a student is a double major in math and finance? Well, double major meaning you're in the intersection right here. So these are the number of students that are double majoring. So since we're looking for probability, we're going to take that number divided by the total elements in our sample space. So probability that the student is a math major and a finance major. So that's going to be what's in the intersection. So we're going to go ahead and take our intersection, that's 5 out of our entire sample space. That we know it's right here, 100. So this will be 5 over 100. And then you just simplify that number. So I'm just going to give myself a little room. Looks like I'm unable to, but if you simplify this, you'll get about 0.05. So that's the probability for the first part. So let's get rid of this. For the second part, we want to know, find the probability that a student is a math major, given that he or she is a finance major. So now this is a conditional probability. Let's set up the formula. So for B, probability that, so here's our given. A student is a math major, given he or she is a finance major. So finance here, math here. That's what we're looking for. So by using the conditional probability formula, this is probability that the student is math and finance major over probability that the student is a finance major. Okay, so what's the probability the student is a math and finance major? Well, that was the answer to part A. So this is 0.05 divided by probability that the student is a finance major. Well, finance, so that's all of this divided by our sample space. So let me go ahead and figure that out on the side. Probability of F, that's going to be 40 out of 100, because there are a total of 100 we have. This is going to give us 0.4. And that's what I'm going to replace right here. So this is going to be 0.4. And then if you put this in your calculator, this will simplify to 0.125. So there you have it. That's the answer to both of these questions. I hope this makes sense. This is a nice way to kind of understand Venn diagram and probability and conditional probability all together. All right, I hope you enjoyed. Take care, everyone.